Today we are going to see stepper motor control using 8085. Right. Now consider now here we are having a stepper motor. The stepper motor will rotate 1.8 degree for each signal. Right, 1.8 degree for each signal. Then if you are having 360 degree, then divided by 1.8, you will get now that one as 200. The 200 is in hexadecimal we are having now as C8. So for one full rotation, then we record the C8 times of pulse. C8 times of pulse we have to give, then it will rotate around 360 degree. So for one full rotation we record C8, right? So here we are having a C register is used as a counter. Then we are giving the value C8. So C8 for one full rotation. If suppose you want to have that half rotation, then divided by 2, we will get now the 64. So this is half rotation, that is 180 degree. Now if you are having, you want to have that 90 degree, then you have to give that value as 32. So divided by 2, we are getting now 32. 32 is 90 degree. So according to your requirement, then you have to set that corresponding value. So if you are having 1.8 degree for one rotation, one pulse, right? Then if you want to you multiply, you divide that number with that one, then you will get now the corresponding value you want to set now for rotation. Right, now you are giving that value. Initially you have to give the counter value as C8. So we need, now here we are requiring one full rotation. Right, then here actually we have to set that 8255. 8255 is a programmable peripheral interface. We already explained something about that programmable peripheral interface, where we are having now that one. So we are having that control word. In that control word we have to give the control of that port A, port B, port C, right? So port A, you are configuring that port A, port B, port C, right? Here we are using only port A. So we are using only port A. So you have to concentrate on the configuring that port A. Port A as output port. And also we are having now that one as symbol IO mode. Symbol IO mode. So for symbol IO mode, so first one T7 is IO mode. T7, right? Then we are having that here symbol IO mode of that group A, group A control. So you have to give now 00 next bit. Then we are having port A considered as output port, we are giving 0, right? The remaining whatever it may be, just I am giving now the remaining is you have to consider as all are 0. So you have to set that 80 on the control where the port A configured as output. So our requirement is you are having your port A is connected with the stepper motor. The stepper motor is having that 4 line, then this is connected with that port A, connected with that port A. Port A we are having that connection, right? So that one as we are having now that connections. Then here you have to set the control word as 80. So we are setting now the control word as 80, 80H in the, so control word as we are setting now the port A is configured as, so port A is configured as, so everything is output port. So that is your right, but we are using port A, right? Now here we have to consider now in that stepper motor we are having now that main 4 stator is there. So for that stator if you have to give now the proper signal, right? So that is here we are energizing one stator, then this is one stator energizing, then you are rotate right, then we are getting now that one as here we are having now that one as here rotate right. So rotate right is this one is coming to here, right? So rotate right, this one is coming to here, this one is going to that one, right? So rotate right. So this is this. If you are having that RRC one command as R rotate right, sorry, rotate right, then this is value is hexadecimal, that value is 11. So this is one bit 1 then this is another one, so we are having now that 11. So we are initializing that with 11. Then if you are doing that rotate right, then you will get now that value is 88. Then once again if you are rotating right, we are having that value 44. Then another rotation, you are getting now that one as 22. 22. Then we are coming, next rotation is coming to initial position. So here we are having now, that is we are having now that one as 11, right? So that is here the first 11 is going to energize here, then second 11 is going to 22 is going to energize here, right? Then 44 and 88, and then we are going to have that 11, and that manner we are giving that the clockwise rotation of that motor, right? So here how do you do that one, right? So move immediate A 11 and we are pass on to port A. So port A is energizing that one pair of that one is going to, so we are having now, this is energizing now, that in that manner we are going to have now that rotations, right? Now opposite rotations now, right? So this is 11, then here we are having, so around 4 pair of 4, right? So this is we are having now something here, I will erase it now. So we are having now 4 pair of coil and it will go for one pair is we are connecting with 11 is going to energize one pair and on another pair and so on. 4 pair is going to have that one energized. Then we are making the north pole south pole changes here. Then it will rotate in the clockwise directions. Right here, once again I write it. This is one pair. Then here we another pair, like we are having another pair of, so around 4 pair of stator is there, right? So one pair is energized by 11, another pair is energized by 22, another pair is energized by 44, another pair is energized by 88, another pair is energized by 11. So in that manner if you are doing now, then we are getting now the clockwise. So you have to use the rotate right for clockwise rotation. Right now here in between the file you have to give the delay, right? So we are sending now the port A, output port A. So here we are having that control address, the address is 43, then port A address is 40, and then we are having now that one here you have to save that flag register content before calling the delay. The delay is going to use the flag register. Then we have to preserve the flag register content. So we are saving that flag register content into stack. So push PSW is, the PSW is the flag register. The flag register content is going to push into the stack. Then while after completing the delay, we are popping that PSW. Now the control word is restored. We are popping out from the stack. So the control word is restored. Then we are calling that rotate right, and then we have to give the decrement that C. So C is a count, the count is going to be decrement one by one, right? Then it will go for around C8 rotation. Then we are getting now for each pulse it will do that one 1.8 clock pulse, right? So 1.8 clock pulse, so we record the C8 1.8 times if you are giving now, then it will rotate 360 degree. So that rotation is over. So here it will go for one full rotation. Then after one full rotation, then it will come here decrement, then no zero, it will go to L1. So it will go for one full rotation of a cycle in the clockwise. So we are having now the clockwise rotation, right? Next we are having now the anti-clockwise direction. So we are having the same program for, you are repeating that one, and you have to get now. Now you see this one, the same program. So already we are having that value either 11 or 22 or 44 or 88, in any one of that value is there. So that one is going to have the accumulator. So the accumulator is having this value. Then from that value we can start now. So here you have to send that port this value to port A. So the address we are having, that control signal is going to have now any one of that value, right? So suppose you assume that one, this is here 1 1 again, right? Now Here the same program is repeated now. So that is we are calling now that we are preserved the flag register and we are calling the delay, and then we have to, why we need to have the call the delay is, if you are giving that one pulse, then for rotating 1.8 degree, then it will record some delay. So you have to give the delay between that one. So between that 180 degree we are giving the delay, then only it will move to that one, right? So if you are changing the delay speed, then we can increase the speed of the rotation, right? That is we are going to see now, right? Next, here you have to give now, this is a RLC is used for anti-clockwise direction. So RLC is used for anti-clockwise direction. So we are having now the RLC is going to have now, this is 11, and then we are having now the RLC, right? So here it is moving to here. So that is here 0 0 1 0 0 0 1 0. So 11 22, and then we are giving now that one 44, and then we are going to have now 88, right? So that is 88. So if you are having in the RLC rotation, then it is going to have that one anti-clockwise direction of rotation. So it is going to have now anti-clockwise direction of rotation motor. So we are having the port A is connected. So in that port A we are giving this value, then the stepper motor start rotating that 1.8 degree for each pulse in between that 1.8 degree, 1.8 degree between that one, right? So that is here also we record that we record that one as C, move immediate C88, right? So C8, that is record now, right? So that is, I think it is missing now. So here we are going to have that one in between. Here we record move immediate C8. So already the C is going to exhaust as 0 and come out that previous loop. So one clockwise rotation, after one clockwise rotation, then that C is going to have that one 0 0, then it will come out. Then at that time, then we have to reinitialize that C as C8, then you have to start now, right? Then only it will coming back to that another clockwise rotation, right? Then this anti-clockwise and clockwise rotation is continuously moving now. Then for that, once again, then we have to reset that C8, and then you have to jump to L1. Then that clockwise direction, anti-clockwise direction is continuously rotating for one clock speed. Suppose you want to have that off clock speed, then in the three place of that move immediate C, you have to put it now 64, 180 degree rotation of that clockwise. So 180 degree rotation of clockwise, and another 180 degree anti-clockwise, 180 degree clockwise, anti-clockwise. In that manner, if you are moving now, then we record C, right? So 90 degree as we are having now that this one, right? So that wiper motor is going to have that one, right? So here we have to move that one back and forth, right? For that we need to have that one CS32, right? So that is we are having now the program, right? Now we're going to see that delay. Actually we can write in many way of delay program. Here we are using now that total, here we are having now, and the outer loop is f of, then inner loop is f of, right? So here we are having now this f of is going to have that one, then f of time. So that inner loop is we are having use that D register, then outer loop we are using C register, right? So that is here totally we are having now f of and f of time of that data. So that is we are recording that delay, one delay columns, right? So this is a random delay, right? Now here we can set that value, the C register value in between. If you are giving that 0 f to f of, then we can varying the speed, the speed of motor, right? So if you are increasing the delay, then it will increasing the delay, it will slow the speed, right? If you are decreasing the delay, is a high speed, right? So this is high speed to low speed, right? In between, then we are having some value, then the speed of the motor we can vary, we can change, right? So that is here move immediate C, the C is outer loop, move immediate C is outer loop, then move immediate D is inner loop, right? So the inner loop we are decrementing then until 0, right? So this is you are going to have now this inner loop, right? Inner loop is continuous for f of time. Then we are having now that outer loop is going to have that one another f of. right? So then here we are having now that move immediate C, then we are going to have that one f of is going to decrement that C, then it will go for outer loop. So once again that reinitialize f of, then we have to continue now, right? So this is a simple way of writing a program, and then you have to give now return, right? So you are having changing that value, then we can change the speed. So that's all we are having now, the stepper motor control using 8255. Thank you.